All right, so we've covered sending more than one value from Arduino to P5 using a delimiter to separate our two variables, our in the example we've done before, um, an analog input like a potentiometer or a photoresistor, and a digital input like a button. Um, and as we've discussed, you can increase the number of values that you're sending across from Arduino to P5 rather easily by just adding another delimiter and another piece of information onto there. And then your P5 sketch will break that into an array of however many elements as there are pieces of data coming across in your message. Um, and the way that it does this is through this split function that's going to take a string, look for a delimiter, and break that into elements of an array. But the difficulty in doing the communication process the other direction is that Arduino does not have a split function. It doesn't automatically have the ability to break things apart. So what we're going to use instead is a method called substring. And substring is going to allow you to take a string that's being sent across from P5 across the serial connection to the Arduino and break it up into discretely sized chunks. And so then it's important for us to make sure we're very conscious of how we're formatting our data. Because if we're sending across like a number that ranges between 0 and 255, 0 is 1 character long, 255 is 3 characters long. We could get away with this by going into using character encoding because characters are encoded in a single byte, but messing with data types like that can get a little messy. If you want to streamline your protocol, we can definitely talk about that more, and you can look into translating between the various data types. But for now, we're just going to stick with sending messages of a defined length. So first things first, let's look through our P5 sketch to see what's happening there. So similarly to our previous P5 sketches, we're going to have an object defined that is going to be our serial port. We have to define our port name, which is information we can get from the P5 serial control application, which we'll be using, as well as through the Arduino menu, the IDE menu interface, we can go through the tools port and see the address of the port to which our Arduino is connected. Next up, we're going to declare and initialize our variables for what data we're going to send across. And in this example, we're going to be illuminating a green and yellow LED. Partially just because those are very simple. There's a yes or no. It's a binary setup of information. So just starting simple, we're going to be sending zeros and ones, or rather A0 and A1, or a 1 and a 1, or a 0 and a 0, to determine which of these, if any, or if both, are going to be illuminated. So back to our P5 sketch, we're going to start out initializing these Boolean variables as false, which is going to correlate to both LEDs being off initially. Now we're going to send a message. So we have our variable called MSG, message, and we're starting out with an array with 2 elements and then an end of transmission character. You could choose whatever you want. I've just chosen an exclamation point because I'm going to have P5 yell at my Arduino. But you could choose an asterisk, a left parenthesis, a curly bracket, whatever you want, doesn't matter. Just as long as the protocol is encoded as well into the Arduino code, which we'll be getting to shortly. So we're going to be, I'm just initializing this array with those 2 values, so it's set. Standard stuff here, I didn't like the outline on these ellipses, but don't worry about that too much. We're going to make an instance of that serial port object. We are going to have our list, which if we scroll up to the very top of our console, if it's still there, oh, it might not be there anymore. We'd see our socket being opened. And most importantly is this got data function, right? So the got data function is going to make sure that we, oh, actually, sorry, I'm getting myself mixed up. We're not going to be even using the got data function because we're not, in this example, not sending any information from the Arduino to P5. I've just made this a very simple example where we're just communicating from P5 to Arduino. So if you wanted to have two-way communication, then you're going to need to combine the previous P5 examples that we've gone over. So everything that's going to happen for us is going to be down here in the draw function and this mouse pressed function. The mouse pressed function is just going to be determining which one of these circles we have clicked on, our yellow circle or our green circle. So let's just start there really quick first. We had those Boolean variables for yellow and green that start out false. And when I click on our yellow, if we see here, we have an if statement that's determining if the distance from the mouse position to the center of our ellipses. I might update this code to have more comments and variables so it's a little bit easier to read. If our mouse is within this circle, we're going to toggle the Boolean value of our yellow variable. And same for green. So this is both false. Yellow is now true. False. I just clicked a couple times. And we can see down here in the console, I've translated those true and falses to zeros and ones. So that's all. This mouse press, this is just about our user interface, as are these ellipses. I mean, we're toggling this Boolean value, and that's what's really driving what's happening. So we have our conditional statements here where we say, if yellow is true, then the first element of our message array is 1. And otherwise, if our yellow Boolean variable is false, the first element of our message array is set to 0. And now we have our conditional tree for green. If the Boolean value is true, the second value of our message array is 1. And if it's false, 0. And we're not touching that terminal character of our array. That's going to stay as, in this example, an exclamation point, which is going to signal the end of one message and get the Arduino ready to read again to keep our data nice and clean. Finally, we are going to both write to the console and send to our serial connection. And we're going to use the function join. And the join function is going to collapse an array down into a string. And it's going to separate each element of the array by a different delimiter. But we don't need a delimiter in here because we're formatting our data to be just the same length. And so the second parameter that we use for the join function is just an empty string. There's nothing in there. It's just two quotes with nothing in between them to say that we're not going to separate those elements when we smash them together into a single string. And that's it for our P5 sketch. And really, I mean, I could get rid of all of the user interface and just have this send a string over if I didn't need to have anything dynamic happening. So now moving on, we're going to look at our Arduino code. So the Arduino code right here, we are going to start out with declaring and initializing our incoming data variable, which we're going to set as a string data type, because remember, Arduino is a strongly typed language, or an explicitly typed language, in this is what I meant to say. So we're going to say that this variable incoming data is a string, and we'll just initialize it with some value. I chose 0, 1, but it could be 0, 0, 1, 1, whatever. That's just going to correlate to what's happening with our LEDs if there's no connection present. in our setup function, we need to declare our pin modes and begin our serial connection and declare that baud rate. Next up, we're down into our loop function. So we're going to be repeating this over and over. And if the serial connection is available, if it's not 0, if it's not false, then we are going to use the serial method read string until. And so what this is going to do, like the difference between read string and read string until, serial.read is going to work until there is a timeout. What we're doing is we're saying read string until we hit that end of message character that we defined in our custom protocol. In this case, an exclamation point. And when we get to that exclamation point, it's going to chunk it off. That is our message. Next up, we're going to just do a trim method on that string just to make sure there's no white space, no nonsense going on that can mess us up. We will print that to the serial monitor, which is just so we can look at it in our P5 serial control console. This line of code, we could comment this out, we could delete it. We could replace this with our two-way communication situation with using those delimiters sending data from Arduino to P5 from our previous example. And now let's get to our conditional situation here using substring, because remember, we don't have that split function at our disposal in Arduino. So what we're going to do is we're going to use substring. So substring, let me just switch up my view here. Substring is going to look at the address, the location of different string or different characters inside of a string. So for our string that we have, our very beginning string that we have is 0, 1, exclamation point. So we have position 0, position 1, position 2, right? So the substring method is going to be applied to our incoming data string. Is that on screen? Let me make sure I'm not going off screen. Oh, it's not. Ugh. Our incoming data string, we're going to apply the substring method dot substring. And then the parameters of this method are the beginning and ending position of what we're going to extract from this larger string as a whole. It looks like it's saying oi. I kind of like that. That's good. So for our first bit of information, we want to go from position 0 to position 1. So substring 0, 1. And this is going to give us equals 0. For our second substring, we're going to have it go between positions between positions 1 and 2. So incoming data substring, that's just ditto marks, 1 and 2, in this case, equals 1. So that means we have now successfully separated our two values that we're sending across. And we just don't do anything with our exclamation point. That's just there to signal the end of one message. So, okay, continuing on. So our conditional structure, if we say, if our first value is 1, we're going to digital write high to pin 2, which if we look back at our Tinkercad circuit, that would be turning on our yellow LED. And if we are receiving a 0, which is in an else if that's linked to our if statement, then we are going to digital write low to that same pin, thus turning off our yellow LED. The next thing we're going to do is we have a separate if situation going on here, where if that second digit is a 1, we're going to digital write high to pin 3, which is connected to our green LED in this example. And once again, if we get a 0 in that position, we're going to turn that LED off. So now let's just take a look at that in action. Well, this isn't going to be doing anything. We're going to look at it in real life. So first of all, we will go to Arduino. We'll make sure this is loaded up on, oops, I need to close my serial connection here. Oop, this looks like it has, there we go, close that. So remember, if you have your serial connection enabled in P5 serial control, then your port will be busy and you will be unable to load your sketch. So let's just verify that everything looks good. I'm on port, I'll just remember 142301. Load that up. If we successfully load, we'll see done uploading. And I'm just going to open up my serial monitor just to see what's happening. We're not getting any new information. We're just seeing this initial value of our incoming data string being printed to the serial monitor here. So that looks good. I'm going to close this serial monitor. And now I'm going to go to P5 serial control and go to this drop-down menu, select the proper port, and click open. And now I can see that I am connected to 142301. And now let's just look in this console just to make sure everything's good. We're getting data, that's good. And we are seeing that very same initial value of incoming data. So that's good. That means that our Arduino is indeed sending out the message saying, this is what I've received. Or in this case, this is what my initial value of that incoming data variable is. So we are ready now to go to our P5 sketch. We go here, and now if I run this, now let me flip my camera around so you can see these LEDs go. So now I have my LED Arduino set up here where I just have very simple 2 LEDs connected through my 220 ohm resistors to limit the current that goes through these 2 pins 2 and 3. So now if I click my yellow circle, every other click is going to toggle that value. And we can see down in the console where we're also printing out the value of the message that we're sending. We can see 1 0 exclamation point. So that means our yellow is on, our green is off, end of message. Turn green on, it should be 1 1 exclamation point. Both of our LEDs are illuminated, and that's our message. And I can control these click, 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 click. And so this, right now we're sending very simple information here, right? We're sending just the, just a 0 or a 1. But what we can do is we could send any type of information we want. Like I said, you could, if you want to get really streamlined into it, you could send bytes or characters, which are essentially bytes. Or if you want to just stick with sending strings, you could send a number of a certain length, and that would correspond, that would necessitate that you then change the length of the substring that you are dividing by in Arduino. So I would probably, if I was sending a 2-digit number, I would maybe send something like this. Or maybe if I'm sending a 3-digit number, like a 0 through 255 value, I might start out with something like this. And I would, instead of having between positions 0 and 1, characters 0 and 1 in our string, I would have 0, 1, 2, 3. So I would say, if this is equal to 0, 0, 0, or I'd probably actually be doing some sort of a mapping instead of just doing this binary conditional structure. I could, but I mean, basically I would be changing these ranges. So I would be having from 0 and 1, I'd have 3 through 1, 2, 3, 4, 5, 6. So depending on what kind of information I have, I'm just going to undo that so I don't accidentally save that and wonder what the heck I was doing before. Depending on what kind of information I'm sending across, I can change the length of that message. And remember, because there's data going one way does not preclude data going the other way. Because remember, there's the RX pin and the TX pin. There's separate conductors for transmission and reception. So we can be sending multiple values out and receiving multiple values simultaneously to our heart's content. Well, there is an upper limit that's partially based on that baud rate. However many messages you can send will be determined by how long your message is as well.